Okay, this section is on solving a quadratic equation by the quadratic formula. So in this section, you are told that if you have a quadratic equation, ax squared plus bx plus c equals 0, then there is a formula that can allow you to find the roots, and that formula is obtained by x equals minus b plus and minus b squared minus 4ac all over 2a. So you can consider listening to the quadratic song that I've uploaded onto the website, or you could consider this story. Okay, there's a negative boy who couldn't make up his mind about going to a radical party, and the square boy missed out on his chance with 4 awesome chicks, and the party was all over by 2 a.m. Okay, so this is the quadratic story, and for some students it helps them remember. Okay, so maybe you want to try that. Now let me show you how to use the formula. So supposedly I say, can you solve 4m squared equals 6m plus 1? What happens is the variable in this question is m. So variable is m. So watch out for that. Unlike the one in the formula where the variable is x. So because it's x, the story starts with x equal. In our case, we have to go m equal. Okay, but the story is the same. Negative b plus minus b squared minus 4ac all over 2a. And what's a and what's b and what's c, for you to figure that out, you're going to have to bring all the terms to the same side. So you're going to have to rewrite as 4m squared minus 6m minus 1 equal 0. So a is referring to the number that's next to the squared term. In this case is 4. B is the number that's next to the letter. Okay, the one with no exponent is negative 6, and C is the one with no variable next to it, so it's negative 1. So substitute all those values in there. So it's negative b is negative 6, plus minus negative 6 squared minus 4 times of a and c. A is 4 in this case, and c is negative 1, and the whole thing is divided by 2a, or 2 times 4. So what you have is 6 plus and minus square root of. So let's work out what's in the radical. Negative 6, when you square it, is 36, and minus minus is plus 16, so that comes out to be 52. So we're talking about square root 52, and this is where I hope you still remember from the earlier chapter that square root 52 is really 4 times 13, which reduces to 2 root 13. So you do have to write it as 2 root 13 all over 8. But if you stop there, you're still wrong, because you notice there's common numbers everywhere, right? There's something that can divide them all. So at this point, you have a split. You can choose to do it by factoring, which is a more formal way to do it, and that's the proper way. Take out the 2, so you have 3 plus minus 1 root 13 all over 8. And the number that you take out becomes a factor, which you can now reduce. So the final answer is going to be 3 plus minus root 13 all over 4. So that's the correct answer. Alternatively, you could try to go from here to here directly using a shortcut. So the method 2 is where you cancel each common factor. So your 6 plus minus 2 root 13 over 8. Look at the 6, look at the 2, and look at the 8. It's common everywhere, and it can be reduced by 2. So the 6 becomes a 3, 2 becomes a 1, and 8 becomes a 4. When you do that, you notice you can also get the answer. Okay, so the one where you cancel each common factor is the faster way to go, but make sure you cancel from every single factor, not just the front. Okay, you got to be from every, not just the 6. You got to do it from the 6, from the 2, and from the 8. Okay, let's look at a second example. Let's look at example 2. Can you solve x squared minus x minus 2 equals 0? So this one, you notice if you try, it is actually factorable. It becomes x minus 2, x plus 1. And so when you set each factor to 0, tells you x is 2. And when you set x plus 1 to 0, tells you x is minus 1. So my two answers are 2 and minus 1, which is a lot faster, right? But alternatively, you can also choose to do by quadratic formula. So this is by factoring. Okay, this is by factoring. Let me show you how I could do it using formula. So assuming I didn't manage to factor it, I couldn't find my factors. So let me try factoring by, not by factoring, by formula. So A is 1, the B is negative 1, and the C is negative 2. This time my variable is back to x, so my equation is x equals negative b plus minus b squared minus 4ac all over 2a. Okay, so negative b in this case is negative 1 plus minus b squared, so it's negative 1 squared minus 4 times of a and c. A is 1 and c is negative 2, and the whole thing is divided by 2a, or 2 times 1. So it's 1 plus minus, let's deal with what's inside. Negative 1 squared is 1, minus 4 times 1 times negative 2 is plus, because 2 minuses, right? And 4 times 2 is 8. So that comes out to be 9, meaning root 9. So this is what you notice. When it's factorable, the piece that's in the radical is a perfect square. So this piece inside the radical, which later on we are going to find out that is called the discriminant. Okay, so this piece inside is what we call the discriminant. So we're talking about that in a little bit. But let's continue. Root 9 is 3 divided by 2. So because it's a rational number, you're going to have to break it up as 1 plus 3 over 2 versus 1 minus 3 over 2. So there's really two answers there. So 4 over 2 is what you call 2. And 1 minus 3, that's negative 2 divided by 2, which comes up to be negative 1. So you still get the two answers, 2 and negative 1, just like what we got over here, except that we kind of had to work a little harder. Okay, so factoring is the faster way to go. Thing is, not everything is factorable. That's why we have to have the quadratic formula, okay, to deal with the ones that are not factorable. And let me show you other examples, like, for example, 2y squared equals negative 11 minus 6y. So you're going to collect everything one side. You have 2y squared plus 6y plus 11 equals 0. So this next example is an equation where it's not factorable. So this is where you have to fall back on the quadratic formula. A is 2, B is 6, and C is 11. So I do have to remind you to make sure the variables are in descending order of exponents. Okay, so they have to be in the correct order for you to know who's A, who's B, and who's C. So make sure you rearrange them. And this time my variables are in X. So variable is in Y. Not X, sorry, Y. So that's why my equation starts with Y. Y equal negative B plus minus B squared minus 4AC all over 2A. So that's the formula. And so negative 6 plus minus 6 squared minus 4 times of A and C, so 2 and 11, all over 2A, which is 2 times 2. So that comes out to be negative 6 plus minus square root of, so let's deal with inside. 6 squared is 36 minus 4 times 2, that's 8, so it's minus 88. So that actually comes out to be negative 52. The difference is the discriminant, which is the number on the inside, okay, is now a negative number. And this is equivalent to asking you to take square root of a negative number, and that's not real. Okay, so the answer to this question is no real solution. Okay, so telling me it's not a real number is not the end of the story, because the question is asking you to solve. So make sure you answer as no real solution. So let's try to summarize here. So let's do a little summary here. Okay, so if you're given ax squared plus bx plus c equals 0, so you know that that means that x has to be negative b plus minus b squared minus 4ac all over 2a. So the piece that's inside, like I mentioned earlier, so 4a squared minus 4ac, that piece is what we call the discriminant. Okay, and we denote it with the letter D. You notice that in the last case, you notice when D is negative, that's when we say that there's no real solution, right? And in the event if D is more than 0, there will be 2 real solutions, meaning the 2 solutions are different. So sometimes we call them distinct real or different. Okay, so different numbers, different real numbers. Okay, and what happens if D was 0? So equivalently, you are trying to take square root of 0, so you end up with only one solution. So this D tells you a lot of things, right? When it's less than 0, it tells you it's no solution. When it's more than 0, there's 2. And when it's equal 0, it actually tells you there's one real solution, or equivalently, we call them as repeated roots, meaning the 2 solutions are really the same thing. And just now I mentioned to you, if D is a perfect square, then the trinomial is factorable. So if you refer to the earlier example, you notice there's one where we could factor, and that's because the D that we found was a 9. So a perfect square is referring to numbers like 1, 4, 9, 16, 25, those. Okay, those are what you call perfect squares. So if your discriminant are perfect squares, then the trinomial is factorable. Okay, so that's just a checkpoint for you. Okay, so let's try one more example. Let's try example 4. So this time let's deal with fractions here. So supposedly I have, okay, can you solve 1/4 x squared minus 3/8 of x equals 1/4? Now unless you like fractions and call it as so you, of course, you have to bring them over first. So it's 1/4 x squared minus 3x minus 1/4 equals 0. And if you like, you could go a is 1/4, b is negative 3/8, and c is negative 1/4. But no, bad idea. Okay, so it's very difficult. So recommended is to clear the fractions. Clear the fractions. That's what you should be doing. So what you should do is multiply the entire equation. So right now you have 1/4 x squared minus 3x minus 1/4 equal 0. So you could choose to multiply the entire equation by 8, right? So you multiply 8 throughout the equation, of course, including the 0. And so what happens is 8 times 1/4 becomes 8 over 4, which is 2x squared. 8 into 3/8 is just 3x. 8 divided by 4, that's minus 2, right? So all of a sudden it clears up, okay? So the equation becomes 2x squared minus 3x minus 2. So this is where I was mentioning to you earlier, you could check the b squared minus 4ac minus 4ac. In this case, the a is 2, the b is negative 3, and the c is negative 2. So negative 3 squared minus 4 times of a and c. A is 2 and c is negative 2. So that comes up to be 9 minus, so that's plus 16, which is 25. Aha, perfect square. Which means that is factorable. So let's see, is it factorable? So let's see, 2x and x. 2 and 1 minus and plus. So yes, it's factorable. And so 2x plus 1 equals 0 tells me 2x is negative 1, or x is negative 1/2. And x minus 2 is 0 tells me x is 2. So that's two answers, negative 1/2 or 2. Okay, two answers. Or if you like, you can still use quadratic formula. Okay, so the alternative is to use the quadratic formula. And so that means that x is equals to negative b, which is negative 3, plus minus root b squared minus 4ac, which is 25. See, I got it from this one. All over 2a, so which is 2 times of 2. So it's 3 plus minus 5 over 4, which splits into two answers. That's 3 plus 5 over 4, which is 8 over 4, which is 2. So that's my 2 right there. And 3 minus 5 over 4, which is negative 2 over 4, which is negative 1/2. That's there. So you still get the same two answers, but it's using formula versus using factoring.